So in this video, we're going to go over linear inequalities with one and two variables. They're pretty straightforward. So first, let's just say we have an inequality such that x is greater than or equal to 5. Well, we would just do this with a number line, and we'd say when there's a 0.5, and this is our positive and our negative sides, that this would be the solution set. That it's everything above 5. But we can see that it equals 5, so we'd put a solid dot. Another way to do this is at 5, you'd put a square bracket and then fill in this. And this is our x values. So that's just one variable. So now if we had two variables, let's say we had x minus y is greater than -5. Okay, so if we just solve this for y, what we see is y is less than x plus 5. So we just go and graph this. That is not a very straight line, but that's fine. Y and x. So now we know how to graph a line. This is just our y-intercept is at 5, and we have a slope of 1. So it's like this. So this is our line, and you can see that I've only sort of dotted it in. So this is our line y equals x plus 5. But the solution is when y is less than this. So that's actually everything down here, right? So this is our solution space. So when is y less than this line? It's less when it's down here. So we can do a test point. So I always use the easiest points I can. So if we tested, so a test point of 0, 0. So we put 0, 0 in here, and that's y is 0, and is that less than 0 plus 5? And that is less than. So that shows us that this point is in our solution space. We dotted it because we cannot equal that point. We cannot equal anything on this line. Our solution space does not include the line. So what if we had something ever so slightly different? Y minus x is less than or equal to -5. So we'd solve for y again. So now what we have is y is greater than or equal to x plus 5. So if we do a graph for this one, let's do the graph a little bit over. So now we have our y-intercept of 5. And we know the line is going to be like this. When you're doing these linear and quadratic inequalities, it's good to just dot in the line, the curve, just because you're not sure. But here we can equal this line. So we're actually going to make a solid line. So it's a solid line if you can be at that point, if it's part of our solution set. So when is y greater than this? Well, y is greater when we're above it. So this is our solution space. And this goes off into infinity. We can use a test point as well. So this is our boundary line as well. Sorry, I didn't draw the boundary line in. It's the same boundary as this, but you can see that our solution space can be above or below it, and our solution space can also have the line or it cannot have the line. But we'll do another test point. We can see that 0.0 is outside of it, but let's test it. So the test point (0, 0), and we just go back here and we have 0 is bigger than or equal to 0 plus 5, and that's not true, which is good because this point is outside of our solution space. And that's how you do a linear inequality in one and two variables.